Objective for principle of moments. First, to plan and carry out experiments to verify the principle of moments using a suspend meter rule and attached weights. Second, the principle of moments states that when a body is balanced, the total clockwise movement about a point equals the total anti-clockwise movement about the same point. Application for principle of moments. The principle that when a system of coplanar force acts on a body and produces at a state of equilibrium, the sum of the moments of the forces about any point in the plane is zero. Suppose, for example, that a light rod is supported by a pivot and that a particle of mass m1 is suspended from the rod at a distance d1 to the right of the pivot, and another of mass m2 is suspended from the rod at a distance d2 to the left of the pivot. The force due to gravity on the first particle has magnitude m1g, and its moment about the pivot is equal to open the bracket m1g close the bracket d1 clockwise. Corresponding to the second particle, there is a moment open the bracket m2g close the bracket d2 anti-clockwise. By the principle of moments, there is equilibrium if open the bracket m1g close the bracket d1 equal to open the bracket m2g close the bracket d2. Calculation. To use the vector definition of moment in this example, take the pivot as the origin O, the x-axis along the road with the positive direction to the right and the y-axis vertical with the positive direction upwards. The force due to gravity on the first particle is negative m1gj, and the moment of the force about O equals open the bracket d1i close the bracket multiplication open the bracket negative m1gj close the bracket equal to negative open the bracket m1g close the bracket d1k. Corresponding to the second particle, the moment equals open the bracket negative d2i close the bracket multiplication open the bracket negative m2gj close the bracket equal to open the bracket m2g close the bracket d2k. The principle of moments gives the same condition for equilibrium as before. The conclusion is each time the ruler balance horizontally, we can see from our results that the anti-clockwise movement about the pivot equal the clockwise movement about the pivot. This verifies the principle of moments.
Assalamualaikum, my name is Rajul Iskandar and I'm going to present my application. First of all, the turning effect of a force is known as the moment. It is the product of the force multiplied by the perpendicular distance from the line of action of force to the pivot or point where the object returns. So, when undoing a nut fastened to a screw by hand, we realize that the amount of force that we need is a lot greater when we using the spanner. So, the spanner will increase the distance between the joint and the force. Because of that, the larger moment we get from the spanner.
Next, for the objective of this experiment is to demonstrate the equilibrium of moment. In order for a rigid body to remain in equilibrium, first condition of equilibrium are state the horizontal and vertical component of all forces acting on a body must add up to zero. The moment of a force or torque is a measure of the force's tendency to cause rotation. It is defined as a product of the magnitude of the force and the perpendicular distance from axis of rotational to the line of action of the force. Last but not least is car engine. As a final example, while this may seem like a significantly more complex example of torque production, it's actually the same principle just on a more dynamic scale. What happening in this case is that the combustion happening inside the chamber is moving the piston up and down. This movement, which is force producer, acts through the rod. But the pivot point in consideration is the center of the crankshaft. This process generates the engine torque. Thank you.